Yes, we can see.
Okay. So this is my disclaimer. So I just talked about the motivation, which is to look at publications in the public domain to help understand current trends and landscape in MI artificial intelligence open source tools. So this is the outline of my talk. First, I'll go over the search strategy, also describing the analysis set, finally giving the results of the findings, as well as highlighting some case examples from Genentech and Roche, and finally ending up with implications and limitations. So the search strategy here is to use a PubMed, and the keywords that were used in the search includes open source, CRAN and OWL package. And it is crossed over with other terms that involves machine learning or artificial intelligence. There's no limit on the year of the search, and the search date was completed around August or September this year. And top pharma company with the highest 2022 revenue were used, and because listing will have different sources of top 10 companies, so eventually we ended up with having 11. And the 11 companies are listed here with Pfizer, AbbVie, J&J, Novartis, Genentech, Merck, EMS, Sanofi, AstraZeneca, GSK, as well as Abbott, and they are not in any particular order, they're just randomly listed. So the search results are as follows, and going from the top, there were about 165 papers that were found, and many of them were removed due to various reasons, including, for example, actually the names of the company may have appeared in the conflict of interest instead of actually being authors of the work. Could also happen that they belong to addresses. Other papers were also screened out. For example, they may not necessarily be open source tools. And within the company authorship, the top company was not involved. And then that screened out and ended up with 46 papers. And then 4 were further removed because they were more like review work. And then the next step, there were another 6 removed because there could be some duplicates that were found. For example, different companies or different search terms may result in duplicates findings. And finally, there were 36 that will remain for analysis. So let's look at some of the trends that we may observe. Here we can see that on the y-axis is essentially the frequency, and on the x-axis is the year. One quite clear trend is that certainly in the latter part of this search years, from 2017 onwards, there are a lot more open source tools with work tied into machine learning or artificial intelligence that are a lot more prominent than in the early 2010s, as you can see. So where were the kind of lead institutions that are involved? It's actually quite interesting to observe that the pharmaceutical top companies, roughly around 50%, and the rest were academic mostly, and then the government institution being a small contributor as well. Another item that we looked at was to understand whether the work was performed by individual pharmaceutical or is it a cross-pharma collaboration. Interestingly, majority of it, over 90% of it was mostly done by one top pharma company. There are some collaboration across pharmaceuticals, but mostly a small, very small portion. And then I think this is, given that it's our in Pharma conference, it's interesting to look at what was the primary open source software that was used in those research. Actually, a majority of it came from Python, about 60%, but there is also a big chunk of it using R, with about 30%. And a smaller portion would involve Java or JavaScript, as well as Python, and also in combination with some other tools. So in terms of journals that had greater than 2 frequency, um, there are a few listed here. The top one that came out with a journal named Journal of Chemical Information and Modeling is the one that has the highest frequency, with 5 of them amongst the ones that were identified in the analysis set, followed by Journal of Chem, Informatics, and then subsequently is Journal of American Medical Informatics Association, as well as Methods in Molecular Biology. In terms of journal categories, we can see that majority of the work are tied to computer science applications, and the next highest is molecular biology, and is not surprising because we also did the search in PubMed. So medicine also came out as one of the top 3 or top 5. Physical and theoretical chemistry, chemistry miscellaneous also identified. And we also see that health informatics and statistics and probability also were some of the journal categories as well. Another interesting thing to look at is whether the machine learning, artificial intelligence work were tied to deep learning. And a majority were not, more general machine learning work, but there are about 15, 16% of work that are tied to deep learning. In terms of the different companies that publish these open source softwares in the past decade, we identified that J&J is actually the one with the most number of publications, followed by Roche Genentech, Pfizer, and Novartis, all having 5. And then subsequently, there are also other companies with a little bit less number of publications of open source tools. And then we also did some subgroup analysis to understand potential changes in the past few years, including for those publications that were less than or equal to 2020 year 2020. The proportion led by pharmaceutical didn't really change much compared to the ones that were beyond 2020. In terms of top 4 highest contributing companies in the 2 periods, we do see that across the board that there are quite obvious increase in the number of publications comparing 2 time periods, 2013 to 2017, to the red color, which is 2018 to 2023. A lot more publications, just as what we've seen in the overall trend that in the recent 5-6 years, there are a lot more publications in the open source tools in the artificial intelligence and machine learning area. I was also interested in understanding what are the Genentech and Roche departments that were involved in it. And looking at it, there seems like to be research and early development is one of the bigger contributors. There are also a couple that were unspecified. I also tried doing something similar, and we were looking at other ways to doing the search with the GitHub instead of PubMed. And one interesting thing is that the way to search things in the GitHub search with keywords is not very easy. So there were only the results that were found were actually very sparse. So I'm wondering whether there's some issue with the keyword search strategy. And of course, there are also some instances where certain keywords, such as if we use the MSD as a keyword search, it would result in too many hits to kind of sort out. So eventually, the results came out to have these companies as listed as the ones that have machine learning related work in the GitHub. But is not very similar to the one that we see from the PubMed. So again, whether the search strategy is questionable or not. So none of these results were further kind of interrogated, given that it's a little bit hard to see whether the search actually is a good one. So now let's move on to some recent case examples by Genentech and Roche, just to give us a feel of what are some of the research work that maybe Genentech, Roche, or other companies have been doing in terms of machine learning, AI, open source tools. So this work is published in Neural Image on reusable benchmark of brain age prediction. And this work is tied to open source software, of course, and is based mostly in high-level Python scripts. It involves both machine learning and deep learning. Another example is one work published in the Journal of Cheminformatics, and it's called Off-Target PML, Open Source Machine Learning Framework for off-target panel safety assessment of small molecules. And in this work, it actually involved both R and Python scripts. And in addition to machine learning, also deep learning was also part of this research work. So we can see that the involvement of using open source tools, both R and Python, are quite popular, as well as in more recent work, in addition to just general machine learning, deep learning were also involved. So let's highlight some of the potential limitations with regards to the work. And as we have seen early on, while PubMed is a good source and also open access that everyone can easily search, it's certainly just one search database. Of course, we can improve on that by doing more work on additional databases. And there are definitely other research work that maybe perhaps published in computer science meeting conferences, but those are not kind of incorporated because we didn't do any abstract search. And published tools that might involve machine learning, but not explicitly as searchable keywords, could have been missed out. Not all year of 2023 was covered, as we haven't gone to the end of the year yet. So as we saw earlier in some of the slides, data is only up to a certain time of 2023. Perhaps there could be a better search, as we saw just earlier that within GitHub, how to identify maybe understanding the trends of those things that are published in GitHub. So I think I missed out the slide on the implications. The implications is that certainly there's some healthy collaborations between pharma and academia. As we saw, it's more like a 50-50 split. One thing is that we don't see a lot of cross-pharma collaboration. So hopefully in the future, I think there are also some initiatives that are presented in this conference that there are some more cross-pharma collaboration, and we hope to see more of those. And there's also an increase in open source tools published in the last 2 to 3 years, as we've seen from a few of our trends. It appears that they're mainly driven by Python languages. So hopefully the people on this meeting can also help drive more dissemination of our programming languages tools. And in particular, I'm interested in the statistics or the health informatics categories. Those are in the lower end, and hopefully in those journals, there could be more encouragement to have these work published. And there are also maybe better ways or better venues to help disseminate these MIAL tools, in particular in the pharmaceutical industry. And I think there's a recent research done by Stanford about encouraging model transparency. So, and having that mindset is also very good and encouraged. So in summary, there's definitely a growth in publications of ML AI open source tools. And chemical informatics, information journals really dominate. And amongst the top pharma, J&J, Novartis, Pfizer, Genentech, Roche, and other bigger contributors, but we hopefully many other companies can also join forces to make things open source and also use more art. So thank you, and also thank you to my colleagues. And that's it. So thank you.